Hello, this is Dr. Tech again for CISP 440, and we're still on question number 4. I'm beating a dead horse again. Um, the reason why I'm making this recording is because after grading about, I would say, about 70% of the class, I just kind of have to explain one thing. The G value is not always guaranteed to be the length of the shortest path. So G of V is not necessarily um, the length of the shortest path to vertex V. It is only the shortest one that we have found so far. And depending on the heuristic, it is possible to find a path to a vertex that is initially not the shortest path, and then later on update the G value to become actually the smallest. So that being said, it is possible for the f value of many vertices to actually be greater than the length of the shortest path from the start vertex to the destination vertex. Even for vertices along the shortest path, that can still happen while the algorithm is ongoing. It is possible to set up heuristics to mislead the algorithm to uh, include to give how should I put it to include vertices along the shortest path, but without the with a relatively high G and as a result F value. So the key is not that we cannot have a single F value that is greater than or equal to G of X. The issue is the issue has to do with this part here. It has to do with the for all symbol. So it has to do with this for all here, because we can we can have individual vertices that does that, but we cannot have all vertices in O that has this property. So that really is the key, because I read a lot of arguments about how G of X is supposed to be the length of the shortest path. Well, it is the length of the shortest path discovered up to this point, but it is not necessarily the actual uh, length of the actual shortest path. So I just want to make that clear, because we in class, I think we made one example where the G value turned from infinity to a non-infinity value, but that turned out to be non-optimal and it was updated later. Um, Edges, on the other hand, well, even edges can be re-explored in the A star algorithm. Um, so once again, just want to make it clear that the universal quantifier plays a very important part of this particular proof by contradiction, because if it's not for the for all quantifier, it would be easy to find examples where at least one vertex in O has a f value that is greater than or equal to um, g of x, or g of the destination at the time. All right, that's all I want to do. Just to make a clarification, just because I have been reading some of the